All right, this is the Penny for Your Thoughts Lab. First thing I'm going to do, put a little hand sanitizer on my hands just to make sure that any germs that are on my hands do not get onto the table. The purpose is to practice and understand the scientific method. So the directions, at the lab there will be a penny, or in this case there's going to be 5 pennies that are going to be very similar to each other. All right, and you're going to have the same person flip the penny 50 times. The coin should go up about 30 meters or 30 centimeters or 1 foot. The penny should always start heads up. Catch the penny on the other hand, but do not flip it to the other hand. Spin the same or similar penny on the table 25 times and record which side it lands. All right, so question number 1. Is the following statement a scientific claim? Why or why not? Remember, for a claim to be scientific, there must be a test for something. So spinning a penny on the table will cause it to land heads up more than if the penny was flipped. So think about if there's a test for that one thing in order for it to be a scientific claim. Now make a hypothesis. Write your hypothesis and be specific as possible. And remember the rules for a good hypothesis. All right, so what you're going to do is flip the penny 50 times. Be sure the same person is doing the flipping the coin, and the coin should go up about 30 centimeters or 1 foot. We want to keep everything the same as possible. Now the penny should always start heads up. That's one of those things that we want to keep the same, right? So you want it to start heads up. So catch the penny on the other hand, but do not flip it. So we want to make sure that we're flipping the coin like this, right? So I think I said other hand, right? But if you want to do it the same hand, that's fine. So about 1 foot, you catch it, record the data. But do not flip it and record the data in the table. So when I did this, I flipped the penny 50 times. It came up 26 times heads, which was 52%, and tails 24 times, which was 48%. All right, now it says spin the same or similar penny on the table 25 times and be sure the same person is doing the spinning. The coin should spin for at least 5 seconds. Record the data. So why I say similar is because it's going to take a while for that penny to stop spinning. All right, so if you notice it's spinning, it's spinning. Now what you can do is you can have, there's going to be 5 pennies. What you can do is sort of spin the same or similar penny across the table. That way we can do 5 at a time. Otherwise it'll take forever. Now if the coins hit each other, you're going to have to start those 2 coins over. But that way we can do multiple pennies at the same time. Now when I did this, I got the count was heads 19 times for a total of 76% and tails 6 times for a total of 24%. All right. Now the conclusion questions. It says identify the independent variable, the dependent variable, and 3 constant variables for this experiment. Now remember the independent variable, what are we manipulating? The dependent variable, what are we measuring? And constant variables, what are we keeping the same? Now question number 6 is, was your hypothesis wrong? Was there a significant difference in the percentages when comparing flipping a penny to spinning a penny? If so, claim why do you think that would be? Remember, for a claim to be scientific, there must be a test for something. So if there was a significant difference, why do you think that is, and could we test that out? Number 9 is identify any random errors that were or could have been in this experiment. Did the random errors affect accuracy or the precision of this experiment? What was done or could have been done to mitigate the random errors in this experiment? So think about this. What was our inability to take the same measurement, to repeat this experiment this exact same way over and over again? Now, number 10, identify any systematic errors that were or could have been in this experiment. Did the systematic errors affect the accuracy or precision of this experiment? What was done or could have been done to mitigate the systematic errors in this experiment? So just think about any systematic errors that could have been in this experiment, and how could this experiment be improved upon in the future to mitigate those? All right, and the last one's a little bit of a fun one. So it says the probability of the American nickel, right? The American nickel landing on the edge if tossed onto a flat surface is approximately 1 in 6,000 tosses. So let's put this to the test as a class. So flip the nickel onto the table as a group for a total of 200 times each. Now, if you were to do this on your own, it would take a very long time to do 6,000 tosses. But if you have a large group of people, well, you can sort of split that up. Now, if all the groups and all the classes were to do 200, right, then that will give over 6,000 tosses. And odds are that one of those tosses is going to land on the side. So you're going to record that off the table, heads, tails, and side. So if I'm flipping a nickel, right, what that means by that is I'm going to let it land on the table and record what it is. Right, so that would be tails. I'm going to do that 200 times as a group. Now, if you were to do this on your own, notice how it started to spin. If you were to do this on your own for 6,000 tries, odds are one of them would come up landing on its side like that. Right? So you have to sort of toss it and let it land on the table. Right? So that is that last part of the lab. And so last thing I'm going to do is put a little hand sanitizer on my hands just to sanitize my hands. And once again, this has been the Penny for Your Thoughts Lab.